So I wanted to give you guys a quick overview of what are referred to as redox reactions. So redox is actually a short form for two separate reactions that are happening, a reduction reaction and an oxidation reaction. And I'm going to discuss what each of those mean because they have to happen together. For those of you that have already taken grade 12 chemistry, you'll find this fairly straightforward, but for those of you who have not, you need to know that this is not a significant component of the biology course, but it's one that will help explain some some of the details that are taking place in some of our reactions throughout the course. Okay, so first of all, a redox reaction involves the transfer of electrons. So you can imagine that in every transfer of electrons, one substance is going to be gaining electrons and one is going to be losing. So a good example of this would be if, for instance, I had a sodium ion, right, and my sodium ion has one electron, and then I'm going to have a chlorine atom, and a chlorine atom, you may remember from chemistry, is going to have 7 valence electrons. And so in this case, we can see pretty clearly, I think, that neither of these guys are happy. My sodium has this one electron that it wants to get rid of because then it will be left with a full valence shell. And my chlorine over here is almost has that full valence shell. It's just in need of one electron. So sodium in this case is going to be transferring its electron to chlorine. So sodium in this case is giving away its electron, and chlorine is going to be gaining an electron. Right? So there are names for this, for the process of gaining and losing electrons. And I just want to quickly go over what those are for you. So reduction. So reduction is actually, it's kind of a confusing name because you usually think of reduction as losing, but in this case, reduction is actually the process of gaining electrons. So we would say that in this case, my chlorine has been reduced because it is gaining an electron from sodium. On the flip side of that, I have my sodium right here, and the sodium is actually losing its electron to chlorine. So it's losing the electrons, and so we call that oxidation. So we would say that sodium has been oxidized. So there's a little mnemonic that goes with this that hopefully will help you remember which is which. Although again, like I said, it's not a huge part of this course, but still important for you to understand. So Leo the lion says grr. So each of the letters in this stand for something. So loss of electrons. Okay, loss of electrons is oxidation. Whereas if I gain electrons, then I call that reduction. And there I go. Okay, so in the previous example, let's just go through that again. I have sodium here that has a 0 charge, right? It's neutral. And each chlorine here has 7 electrons, so it's neutral. And then when it forms this ionic compound, well, the sodium ion will have a charge of +1, and the chlorine will have a -1. So this is just a different way of representing what we discussed above, with sodium donating its 1 valence electron to chlorine. Right? Now, of course, this isn't balanced. So let's go ahead and balance that. I need to have 2 sodiums for every chlorine, in this case, for every chlorine molecule. So when I look at this overall, I can see that my sodium charge has gone up, and that's because it had to lose an electron. And so losing an electron is oxidation. So I would say that my sodium is being oxidized as opposed to my chlorine. And my chlorine I can see has a charge of 0, and then it becomes something with a charge of -1. And that's because it gained electrons. It was reduced. Okay, so I guess, the reduction part comes from the fact that the charge is actually what's being reduced. Going from a 0 to a -1 charge, its charge has been reduced. So in biology class, where we're going to see redox reactions happen are in what we call coupled redox reactions. Okay, in other words, a chain of redox reactions. So it should make sense to you that if one substance is going to be gaining an electron, that it has to gain it from something else, and that something else is going to be losing the electron, right? So that's what we mean by coupled. So for every reduction, there has to be an oxidation, and vice versa, right? So when we talk about them being coupled, though, we also are talking about it being sort of a chain reaction. So, so let me kind of explain this diagram and what is meant by it with you. So if I have A minus, right, A minus, it looks like is carrying an extra electron. So, as I move my cursor, that's going to represent the movement of that one electron, right? So A minus is a substance that has a fairly low oxidizing potential. Okay, let's just think of it as, A minus has the lowest electronegativity, and then D over here has the highest electronegativity, right? So as we move up, A has the lowest electronegativity, then B has a slightly higher one, C has slightly higher, and then D we finish off as having the highest electronegativity, which means that as we move along this chain, this the next substance in the line has a greater ability to attract the electron. And so remember, we're starting with this electron on this substance A minus. So the next substance B wants that electron more. So it's going to go ahead and grab it. And so that electron is now a part of B, of the B atom, and now it's B minus. Now when A minus loses the electron to B, it now returns to being A. Okay, so let's move along with that electron. So now the electron is with this B as B minus. Then it's going to be transferred to C because C is more electronegative, and so C now becomes C minus. Of course, we know that D is the highest, is the substance with the highest electronegativity in this particular chain, and so C minus is going to quickly lose that extra electron to D and return to being C. D is going to grab the electron from C minus and become D minus, right? So that's what we mean by a coupled redox reaction. We have, our A minus is going to be losing the electron, so it's oxidized. Right? And so it's losing the electron, so it's oxidized. But, the thing that's gaining is B. B is reduced, right? So for every oxidation, there has to be a reduction, right? And so when it gains that electron, it's over here as B minus, but then B minus is giving up its electron, so then it's oxidized by C, and so C has to be reduced, and so on and so forth. So it's just a chain of something being losing electrons, then gaining, losing, then gaining. So oxidation, then reduction, oxidation, and then reduction. Think of it as sort of like hot potato or like a tug of war for that one electron. Each substance in line is a little bit stronger, so it's going to be able to grab onto it and pull it away from the weaker substance before it. So all oxidation and reduction refer to are, the substance that's gaining and the substance that's losing. So I know that they're new terms, but the ideas I think are fairly straightforward. And so as I was saying, the fact that these electrons are moving, we call that an electron transport system or an electron transport chain. And so just moving along that chain is going to have an effect on the amount of energy that's produced in both cellular respiration and photosynthesis. But we'll get into the specifics of that a little bit later on. What I want you to understand is just the idea that if one substance is losing, then the other thing is gaining. But when the substance that gained the extra electron has its electron pulled back, that it becomes, it loses the electron and then becomes oxidized again. So substances are reduced and then oxidized, reduced and then oxidized, and so on and so forth in an electron transport chain. So primarily where this is happening has to do with the molecules themselves. And so I'm going to give you a more concrete example instead of giving letters, although this is just to help you understand the idea of reduction and oxidation. But really, you're not going to be asked to solve particular problems like this. I think it'll just hopefully strengthen some of your understanding of reduction. So in this compound here, oxygen, oxygen has a net charge of 0. It's an element, and so it's neutral. But over here in CO2 and in H2O, we can see that in each case it's going to have a charge of -2 because it's in a compound, right? -2. And, particularly in this case of water, you should be able to see that water, that the hydrogen ions are each going to have a charge of +1. And so, but because there are 2 of them, that gives it an overall contributed charge of +2. So if I have 2 times a +1 will give me +2, which will cancel out with this -2 and give me an overall 0 charge for water. Right, and so carbon in this compound, since I have 2 oxygens, each at -2, that means that the charge on this carbon here has to be +4. Right, so already I can see that when I look strictly at oxygen, it appears to me that oxygen has gone from having a 0 charge to a negative charge. In other words, its charge has been reduced. So oxygen has been reduced. So by default, that means that my CH4 compound has been oxidized. And that makes sense. It's reacting with oxygen. But let's just break that down just a little bit more. So in this compound, hydrogen has a +1 charge. And I have 4 of them, so hydrogen is contributing a +4 total charge. And since I only have 1 carbon, in order to make CH4 neutral, carbon has to have a -4 charge. And so let's just take a look at this. And so again, I'm seeing that carbon, in order to go from having a -4 charge to a +4 charge, has to have lost some of its negative electrons, and that means that it was oxidized. Remember, Leo the lion says grr. Hope that helps to remind you of some basic ideas related to redox reactions.